This is Shakil Ahmed. In this video, we will discuss generalized linear mixed effect model for count data. Previously, we discussed generalized linear mixed effect model with binary variable when our variable dependent variable is binary. But when we have count data, then we need to go for Poisson regression, and in case of over dispersion, we can use negative animal distribution, and we can go for the zero inflated models as well. But I will limit this discussion to count models with Poisson and negative animal regression models. I have downloaded the data from National Health and Nutrition and Examination Survey 2018 that consist of different demographic variables and different variables on health and nutritional status of different US residents. And we can see I have just imported data in Excel with the read Excel command, and LME4 is needed for mixed effect models. And we can just see we have 9,756 observation on 962 variables, and the chronic count is basically number of chronic conditions for an individual that is taken as count scale. And you can see we have 0, 1, 2, 3, and 4 uh, values for the count variable. And although the mixed effect model is used when we have repeated measurements for individual observations, or we have clustering effect, we have different clusters and individuals within clusters are highly correlated with each other. But I just tried to check the sex and ethnicity. Ethnicity is people within an ethnic group is tend to be more highly correlated than people from other ethnicity. So we can take ethnicity as the uh, clustering variable, random effect for our model. And we can see the histogram for chronic counts by ethnicity. The histogram is not displaying. I think it should. So this is different distribution of counts for different ethnic groups, and we can also make an XY plot for chronic conditions with age and without basically relationship between chronic condition and uh, age for different chronic different ethnic groups. We can see the pattern using, for example, we can just use. We have previously shown that XY plot is used for this purpose, and you can see how the relationship between chronic counts, that is our response variable, and for it you need the ggplot package. I think latest package. If you have already installed, uh, we have already called here. So we can call lattice package and chronic condition XY plot for chronic condition, chronic counts, and age variable. and we are making it by ethnicity. And we are showing the groups and different points relationship between chronic counts and age, and the layout is 2 by 2. As you can take 3 by 3 as well if you have greater number of groups. And let's see, the data is df as we have already imported. So here we can see the uh, relationship between ethnicity uh, uh, by age and the chronic counts by ethnicity. We have only two ethnic groups, although ethnicity variable consists of different ethnic groups. We have converted ethnicity into only two groups. You can also use the ethnicity for different groups. Uh, this is just converted into two groups, Hispanic and non-Hispanic. And then we can run a generalized linear mixed effect model with a Poisson link. That is, we have a count data, count response variable, and we want to see the impact of age on chronic counts by taking the ethnicity in countries consideration as the people within ethnic group uh, tends to have a correlated chronic condition. Basically, they have more similar characteristic than the people with from different ethnic groups. So we are taking the ethnicity as the random effect, and we can run this and see the summary. As you can see, the AIC value and the BIC value, these are the model accuracy measures, and we have the summary statistics for scaled residuals, standardized residuals, and we have variance for ethnicity, that is our grouping variable, and that is 0.0249, and the age has a positive and significant effect on chronic condition, that is the effect of age. And we can also find the exponentiated age as well uh, to see the change. Although this effect is in Poisson, we take log of counts and then that is equal to mu. So if you want to find the mu, you have to change in mu, you have to exponentiate the coefficient, and you will find the exact age. And then now you can see the significant codes. Uh, the age is significant on has a significant effect on chronic condition, and we can now we can see whether uh, there is an over dispersion in data or not. That can be checked using just comparing the mean and variance of the counts, and also through the histogram that we have already plotted. Uh, if there are inflated zeros, then we need to go for zero inflation models. We have already discussed in previous videos. And uh, for now, we are just running a negative binomial model that will be run with the negative binomial, and the verbose is equal to true means it will calculate the over dispersion parameter theta with an iterative process. You can just run. It will take time as it needs different iterations for estimating parameter theta. It will take a initial value and then iterate, perform different iterations to get the maximum likelihood estimate for theta and other parameters alpha and beta. So it's taking time, just wait, you will get the result. So generalized linear mixed effect model is the basically generalized linear model for mixed effect models. When we combine the linear mixed effect model and generalized linear models, we will get generalized linear mixed effect models. And that is again we need to use when we have clustering structure or we have correlation within individual observation. For example, we have repeated observations for different individuals. Then we need to go for mixed effect models. We have fixed part and we have a random part. So this is just an example. I'm showing the ethnicity as the clustering variable, but this is in practice this is not valid. We can just take ethnicity as the stratification variable, and we can uh, also use ethnicity in the adjustment just as a covariate, and we can proceed. This is not a, a random basically ethnicity does not has a random effect on the chronic count directly. So we should be careful while using a mixed effect model that is a complex model when we have a nested structure. For example, we have different patients in different hospitals, then there will be a clustering effect of different between different patients within different hospitals or within a different practitioners, or we can say within a certain procedure we applied. So in such cases, we need to apply the generalized linear mixed model, and if we are interested in categorical or count variables. Okay. And if we have the continuous variable, we can proceed with simple linear mixed effect model. And this is the result we get. You can again see there is a positive impact of age on chronic condition, and we found similar variance for the ethnicity for the grouping variable, and that is called random effect variance. Uh, this is the variance of basically random error. We have two types of error in such type of models. We have an intercept. Basically, the random effect is a kind of intercept when we use no auxiliary information, no predictor with the random effect, and it will be random. That's why we linked with the error, and the individual error at individual level, that is called the residual, that is somehow different with the random error, random effect error. So we need variance for both the error terms. the, for example, U, that is the error for random effect, and the error for residuals. So that's all about the generalized mixed effect models. Thank you for watching, and uh, if you have any question, you can always uh, write in comments. Thank you.